Hello everyone. We're going to see about the scheduling algorithm, which is called first come, first served. The objective of this study is to find the average waiting time calculation is our objective here. So how are we going to achieve this finding? That's what we're gonna do. So I have given this processes here. There are totally 5 processes, P1 to P5, and the arrival time 02518. These represent the time at which the process comes into the ready queue, and the burst times are 41576, which are corresponding to the processes. And burst time refers to the time it needs. Every process burst time is nothing but the time that process needs the CPU. How long the CPU is needed by the process is called burst time. And the priority of the process is given here. Some priorities, sometimes priorities will be highest if the number is smallest. Sometimes priorities will be lowest if the number is the smallest. Okay, so here in this case we're gonna go having the priority which is lowest means highest priority. Okay, so arrival time based scheduling is first come first serve. Which process comes first into the ready queue, that process will be given the CPU. Okay, if 2 or 3 processes comes into the ready queue at the same time, then we can do one thing. We can use some other parameter to break the tie. We can use a priority, we can use the burst time, we can use many other policies as per the need. But we can go here with the priority if there is a tie in arrival time. But first come first serve is normally refers to arrival time. So whichever the process comes into the queue first, that means ready queue first, will be given the CPU. So that is how the design is. Now we'll just go to the problem. Now we got processes, 5 processes, we got arrival time is given. So the arrival time is 0 for P2. So P2's arrival time is 0. So in this case, so P2 will be given a CPU first initially. So if you see how this goes, it's a non-preemptive. Basically it is non-preemptive. That means preemptive means once a process gets the CPU, or we can say once the process gets the processor, then it will never leave that. It will go on running till it finishes. But preemptive means, this is non-preemptive. Non-preemptive means it will go on running till it finishes. Preemptive means even if a process gets the CPU, we can snatch the CPU from that process. So that is called preemption. So in this case, FCFS, this is usually called FCFS, first come, first served, FCFS. So in this FCFS, usually it is non-preemptive. That means once a process gets the CPU, it will run to the finish. So here P2 starts the started to run. It got the CPU. P2 got the CPU, so it will run from 0 to 4. Okay, so P2 will run from 0 to 4. So because the burst time is 4 units, 4 time units, so it is running for 4. And then if you see this at 4, how many processes came? So P2 is finished. You can just say change the color to blue in case of finishing. So at the 4, how many processes came? These 2 processes came. So it is say we'll put it in green. So because it's waiting. So these 2 processes are waiting. But which one comes into the queue first? It comes into the queue first. P4 got into the queue at time unit 1. P3 got into the queue at time unit 2. So that means we will give the processor to P4. So if we give the processor to P4, P4's burst time is 7. So it will run for 7 time units. It will run from 4 to 11. So that's the time it's running. So at 11, all these people, so this P4 will finish it off. So P4 will finish. P4 will finish. So I'll change the color to blue. P4 finish. Now P3 is there, and at 11 time units, this also comes. Okay, and it's waiting. 8, this also comes, and it's waiting. So all three are waiting. So now which one I should give? Because P3 comes at 2, so we are giving it to P3. Then P3 will run for one burst time. So it will run from 11 to 12. Okay, so P3 will run from 11 to 12. Then P3 is also finished. I'll change the color to blue, and these two are waiting, and P1 comes into the queue before P5. So I'm giving it to P1. P1 run from 12 to burst time is 5. Burst time is 5 means it will run up to 17. Okay, then P5 will get it. P5 will run for 6 time minutes, that is 17 to 23. It will run 23. It will run. So this is how the time minutes are there. You can say it's a Gantt chart. The chart is said to be a Gantt chart. Okay, so this is how things are kind of found out. So now if you want to find the waiting times, P1 waiting time, P2 waiting time, P3 and P4 and P5. I want to find the waiting time. And the TT is turnaround time. Okay, so if you want to find this, let us see how to do. Okay, so because objective is to find the average waiting time. Okay, so here P2, how long is P2 waited? P2 comes into the queue. Now all are finished. I'll just change the color to again to all are finished. Okay, now P2, how long it waited in the ready queue? Can you just see this? P2 got the CPU at 0. It got into the ready queue at 0. So that means its waiting time is 0. So what is waiting time? Waiting time is time, how long a process waits in the ready queue before getting the CPU. So the process spent time in the ready queue, the total time a process spends in the ready queue is called waiting time. Okay, turnaround time is waiting time plus I'll just write it here. Waiting time is, what's the waiting time? Waiting time is total time a process spent in the ready queue. Okay, so that is waiting time. Okay, what is TT? Turnaround time. Turnaround time is nothing but waiting time plus burst time. Turnaround time is waiting time plus burst time. Okay, how long a process takes from the time it enters into the ready queue till it finishes. Okay, that is called turnaround time. Okay, so these two times we are going to find out. So for this P2 got into the queue at 0. Immediately it got the processor. That means 0 waiting time. What is a TT? TT is waiting time plus burst time. Burst time is, this is P2. We are doing for P2. P2 is 0, and then P2's waiting time is 4. So 0 plus 4 is 4 total. Okay. Now let us go with this table. P1's waiting time. What is P1's waiting time? You see P1 is here. It is non-preemptive. So there will not be any more P1s here. There is only one P1. Once it gets up CPU, it will finish it. So P1 starts the running from 12. P1 got into the queue at 5. So what is the waiting time? 12 minus 5, that is 7. So 7 is the waiting time for P1. Turnaround time. What is turnaround time? Waiting time plus burst time of P1. Waiting time is 7. burst time is 5, so turnaround time is 12. P3, if you see, P3's start time is 11, P3's arrival time is 2. Into the queue it came at second time unit, it got the CPU at 11th time unit, so it is 11 minus 2, 9 is the waiting time. P3's burst time is 1, so it is 9 plus 1, 10. If you take P4, P4's start time is 4, and P4 got into the queue at 1, so it is 4 minus 1, 3. And P4's turnaround time is 7 is the burst time, so 1 plus 3, 7 plus 7 is burst time, 7 plus 3, 10. Okay. P5's waiting time is 17, is the start time of the running, and the P5 got into the queue at 8, so 17 minus 8 is 9, so 9 is the waiting time for P5, and the burst time of P5 is 9 plus burst time of P5 is 6, so it is 15. So this is a calculation. So if you see what's the average waiting time, you just have to sum it up. So it is average is 5.6. 5.6 is the average waiting time. Okay, so basically this is what we are calculating. So this is FCFS. FCFS is characterized by non-preemptive nature, and if there is a tie in arrival time, we can use a priority to break the tie, or we can use burst time to break the tie. We can go with the smallest burst time, having more priority once if there is a tie. So that's it. This is FCFS, first come first served scheduling algorithm. Thank you for listening.